so example 1 says identify the leading coefficient, degree, and behavior. Okay, identify the leading coefficient, the degree, and the end behavior. Okay, so with the leading coefficient, there are 2 decisions that you have to make about the LCO. All right, the leading coefficient is either going to be positive or negative. Okay, the degree is where you have to determine if it's odd or even. And the end behavior is where you are going to write your statement. Okay, and I started that for you here. And then as you go forward, you'll know how to do that. Okay, so for part A, and sometimes they're going to have different names. You know how we have f of x, q of x, or g of x? This one is q of x instead of p of x. So you'll see different variables in there. So I have negative x to the 4th plus 6x cubed minus x plus 9. Okay, so the first thing I'm going to do is identify the leading coefficient, and do make sure it is in standard form. Okay, this one is. So Eddie, what's our leading coefficient for this one?
-1.
Good. Okay, so the leading coefficient is -1, and then Sophia, what's our degree for this one?
4.
Good. All right, so the leading coefficient, that's where you determine if it's positive or negative. Okay, obviously -1 is negative. So what that tells us is the graph falls on the right. Okay, now the degree, that's where you determine if it's odd or even. 4 is an even value, so that means that the ends go in the same direction. Okay, and it does say to identify what they are, so we did do that, we identified them, and now we are going to do the end behavior. Okay, so we did the leading coefficient and the degree. Now we are going to do the end behavior. Okay, so the end behavior, remember I told you how this was going to start? This is as x goes to negative infinity, and you can say q of x, or sometimes they even just say like a capital Q. So when you're checking that, I want you to know the different ways that can be written. Now, if it falls on the right side, I usually fill in the right side first. So as x goes to positive infinity, okay, I fill this one first. So if it falls on the right side, that means it's going down. So I'm going to use negative infinity. And I'll say that one more time about how I know that. Okay, so if it's negative, it falls on the right side. Remember that the positive infinity represents the right side. So if it falls, I'm going to use negative infinity. Now the next thing I'll fill in is this one based on whether it's an even or odd degree. If it's even, it goes in the same direction, which means if this side is going down, this side also has to go down. Okay, because these two have to be the same. Okay, so this is going to be your end behavior, this whole thing here. Okay, so it's falling on both sides. And then you could also graph, and you could double check that it is falling on both sides. That would be perfectly fine. Okay, let's try the next one. I know this will take a couple of practice sessions. Okay, so for B you have P of x equals 2x to the 5th plus 6x to the 4th minus x plus 4. Okay, and the only thing I want you to do on your own for this one is I want you to identify your leading coefficient and your degree, and then I want you to tell me what that means, just like I wrote out here, okay? That's all I want you to do on your own for part B. And then we can do that part together. All right, let's see what we got. So, Nina, what was your leading coefficient? Okay, good. And then for the leading coefficient, are we saying if that's positive or negative or odd or even? Positive or negative. And this one is positive. Okay, so if it's positive, it rises on the right. Okay, great. And then, Nathan, what was your degree? Well, say it again. But your degree, what was your degree of the polynomial? Yep. And then, yes, so it was odd, so that means they are going in opposite directions. Okay, and I saw some of you even did your end behavior, which is great. Okay, so remember, with the end behavior, on the last page, I wrote out like the in general for you, so you can always write this out and then just fill these in. Okay, and again, like whether it's P or P of X, that part to me doesn't matter as long as you can fill these in. All right, so we're going to start this off as x goes to negative infinity. P goes to, and we're going to fill in the blank, and then as x goes to positive infinity, P goes to blank. Okay, so remember, what you're saying here is what happens on the left, what happens on the right. So fill in the right side first, because we know that it rises on the right. So if it rises on the right, P goes to positive infinity. Okay, now the odd tells you they're going in opposite directions. So if we're going positive on the right, where are we going on the left? Negative infinity. All right, do you guys think you can do the last one on your own? Not sure, okay. I'll come around. This is R of x equals negative x cubed plus 4. Okay, and let's see if you can do all of this, okay? And once you're done, you can start reading the directions. when you're doing this, generally we just we go in order and we write the left side and then the right side, and then when you're writing it, I know some of you like to write the positive side first. That's okay. I wouldn't mark it wrong. Just when you are checking your answers, you would just like flip-flop it. So if you were checking it and it was the negative first, just make sure that you're checking the first part. So your leading coefficient is -1, your degree is 3, so because it's negative, it falls on the right side. Okay, because it is odd, they're going in opposite directions. Okay, and then I do want you to write these out for your notes. These are things that you'll have to know like the back of your hand, but when you're doing your homework, you don't have to write that part out, okay? So as x goes to -infinity, what happens to r? And as x goes to +infinity, what happens to r? Okay, so again, I like to do the plus side first, the positive. So if it falls on the right, this is going to be negative. And then, Molly, what's going to happen on this side? Yeah, has to be the opposite, okay, because it's odd. All right, questions for me on that? Okay, guys, let's focus here. Lily, this way, Eddie. Okay, so when you have your next example, there are multiple directions here, so we're going to identify whether the function graph has an odd or even degree and a positive or negative leading coefficient. The main thing is that you are explaining how you know. So we are going to be practicing our explanations today. Okay, and then I'm going to give you the graph, okay? So you can watch me graph it, and then I'll give you some time. That's what it is. Okay, so just like we were doing before, we are going to identify a degree as odd or even and a coefficient as positive or negative. So remember, the right side of the graph, okay, just tell me if it's going up or down. In this case, it's falling, so falls on the right. So if it falls on the right, does that tell you about the leading coefficient or the degree? Okay, yeah, so Grayson, what do we know about it? Yes, so negative LCO. Okay, does anybody want to tell me the other thing we know? Yeah, Catherine?
The degree is odd because the ends going in different directions.
Yes. Okay, so the ends are going in opposite directions. So the degree is odd. Okay, so now we are going to write our sophisticated answer. The function has an odd degree because the ends of the graph are going in opposite directions. The leading coefficient is negative, since the graph falls on the right side. Okay, so all you need are 2 sentences. Okay, so 1 sentence about the degree, 1 sentence about the leading coefficient. I know, it's 2 sentences. It's a tough world. Tissues are in the back. Alright, so I want you to try this one, and I want you to try to write out your nice response. And you guys can make notes right on the graph like we did before, or if you are feeling confident and you know, really you can treat the first one like a model, right? The function has a, fill in if it's odd or even, because the ends of the graph are, tell me what they're doing. The leading coefficient is, tell me if it's positive or negative. Like the little notes there. Is that what you mean? Oh, nope. No, so for this one, you're just going to say the function has a, and then what did you guys say, even or odd? This one should be an even, okay, an even degree, okay, and then Caleb, tell me why. Why does it have an even degree? Okay. Yep. So we're gonna. You can say the function has an even degree because the ends go in the same direction. So it's either the same direction or it's opposite directions. Okay. And if you want, you can even make it 1 sentence if you wanted. And the leading coefficient is, what is it? Good. Leading coefficient is positive. And then Casey, why is it positive? Good, because the graph rises on the right. Perfect. Alright, and for, how did you go? The grand finale. This guy. All right, Jackson, can you tell me what you know about the degree? Yeah, tell me why. Good, okay, so the function has an odd degree because the ends are going in opposite directions. And then Connor C, what do we know about the leading coefficient? It's what? So the leading coefficient is going to be positive. Yes, yep, positive. Yes. Rising where? On the right side. Yes. Okay. And we do have to make sure that you do include it's on the right side. Okay. And you have the odd, and then you have the even. Okay. Now the next thing we're going to look at is bracketing the polynomials by team.